Hello everyone. So in this lecture we are going to see the constructed wetland and root zone technology. So what is constructed wetland? Constructed wetland are artificial wastewater treatment system consisting of shallow pond that is usually less than 1 meter depth or channels which have been planted with aquatic plants and which rely upon natural microbial, biological, physical and chemical processes to treat wastewater. So these are artificially constructed shallow depth ponds, and plantation is there. Then they typically have impervious clay or synthetic liner and engineered structure to control the flow direction, liquid detention time and water level. By various such processes, chemicals are considerably removed or settled and clean water is drawn. This chemical includes nitrogen, ammonia, phosphorus and pathogens. Constructed wetlands are most economical as compared to the conventional treatment units, which needs more energy for its process, and this method requires cheaper material. So this is the on-field figure of or on-field photo of constructed wetland. As you can see, these are the shallow depth ponds and aquatic plantations is there. Then there are two types of constructed wetland, that is surface flow constructed wetland and subsurface flow constructed wetland. Again, subsurface flow is divided into two types, that is vertical flow and horizontal flow, and vertical flow again divided into upflow and downflow depending on its moment of percolation of water. Then first type is surface flow wetland. Wetlands, like most natural wetlands, are those where the water surface is exposed to the atmosphere. Water flows over the soil media. A channel or flow bed is dug and lined with an impermeable barrier such as clay or geotextile material. The flow bed is then covered with rocks, gravels and soil. The vegetation is also planted. It is better to have plants that are native to the area. After that, the wastewater is let into the flow bed by an inlet pipe. The usual depth of the wastewater is approximate 10 to 45 cm above the ground level. As the water slowly flows through the wetland, simultaneous process clean the wastewater and clean water is released to the outlet pipe. So this is the diagram of surface flow wetland. As you can see in this diagram, the influent is coming from this inlet pipe, and these shallow depth wetlands are constructed above the ground level. So first of all, we are placing some geotextile material or soil. Above that, some rocks are placed, and the wastewater is flow above this bed media, and plantations have done onto this bed media, and the clean water should be collected from this outlet pipe. So this is the on-field figure of surface flow wetland. The next type is subsurface wetland, subsurface flow wetland, where the water surface is below the ground level. So that is the difference in between surface and subsurface flow. In surface flow wetland, the water surface is above the ground level, and in subsurface, the water surface is below the ground level. In this, water flows below media. No water on soil surface, but subsoil is saturated. The use of subsurface constructed wetland for water treatment began in Western European countries in 1960s and in US in 1980s. So as you can see in this figure, this is the subsurface type wetland. So water surface is below the ground level. Again, subsurface are divided into horizontal flow and vertical flow wetland. As you can see in this figure, in horizontal flow, the flow must be in horizontal direction and parallel to this bed. So in that, the inlet and outlet arrangement such that the flow must be parallel to the bottom line of this shallow tank and should be linear in direction. And in vertical flow, as you can see in this figure, the flow should be, or the sewage should be, percolate into this filter bed instead of in horizontal direction, just like in trickling filter. So the objectives of constructed wetlands are: generally the wastewater generated in the houses is released to the wastewater carriage system. However, it is very difficult to treat the wastewater generated in centralized way in metropolitan cities. Hence, there is a necessity of decentralized wastewater treatment facilities at household level. Necessity of constructed wetland is to achieve the following: to treat the domestic wastewater generated in the house at household level using the constructed wetland, and to test the quality of treated waste by using constructed wetland for other beneficial uses, like recycling of this treated wastewater for the irrigation purpose. So, what is the mechanism, removing mechanism that will happen in this constructed wetland? So, first is organic matter. So, how the organic matters are removed in constructed wetland? So, there is aerobic microbial degradation as well as anaerobic microbial degradation, depending on the depth of shallow ponds. Then, suspended solids are removed in the sedimentation filtration. So because of we are placing that filter media, so sedimentation occurs. Sedimentation occurs in this constructed wetland. The pathogens, the sedimentation filtration natural die of predation UV radiations. Nitrogens, the nitrification and denitrification plant uptake the matrix adsorption. The phosphorus should be removed by matrix adsorption of plant uptake. Metals, the adsorption and cation exchange, complexation, precipitation, plant uptake, microbial oxidation or reduction. Practical approach of this constructed wetland. So as you can see in this figure, this is the horizontal subsurface flow constructed wetland. So for household level, you can construct this number like this, the number of ponds, and you are planting the locally available aquatic plants into that, whether it is surface or subsurface wetland. Methodology. So for the small capacity or for the household level, so in this experimental setup, the bucket with different sizes and dimensions will be used. The vertical bucket as holding tank inlet will be used to hold the wastewater. The water storing capacity of tank will be approximate 50 liters. A rectangular tub of size 62 cm length and height of 35 cm having the suitable outlet. So as you can see in this figure, this is a 50-liter capacity tank for holding the water, and this is the horizontal panel in which we are placing the soil, rocks and other geotextile material, and we are planting the locally available plants in that. Then the vertical pipe will be placed above the tub for distribution of water. Plastic cans will be used for the collection of treated water. Treated water sample will be collected and analyzed in laboratory. The angular horizontal subsurface flow constructed wetland will be prepared as follows. The 3 layers of supported bed in constructed wetland will be prepared with coarse aggregate sand and garden soil. Coarse aggregate of 20 kg total weight will be used for making bottom layer of 10 cm height, followed by medium sized sand amounting total to 15 kg will be added to form a middle layer of 10 cm height, and a small size sieved 6 kg of soil to form upper layer or top layer of 10 cm height will be used in construction of bed. So as explained in this slide, the coarser material will be placed at the bottom and the finer material will be placed on the top. The selective, healthy, small, young, locally available plant will be transplanted into the bed. The rectangular tub with plant bed will be provided with 10-degree slope and kept in the slanting position. And inlet flow and outlet flow of wastewater will be adjusted to maintain hydraulic retention time of 7 days. So sewage should be applied in this tank or pond of minimum of 7 days. So next technology, it's the root zone wastewater treatment or root zone technology. So similar to wetland, the root zone is scientific term used to cover all the biological activity among different types of microbes, the roots of plants, water, soil and the sun. It consists planted filter beds containing gravel, sand and soil. The root zone wastewater treatment system utilizes nature's way of biologically processing domestic and industrial effluent. This effective technology called Decentralized Wastewater System was developed in 1970s in Germany and has been successfully implemented in different countries, mainly in European and America. So nowadays in India, we are also using this decentralized wastewater treatment technology. The root zone wastewater treatment system makes use of biological and physical treatment process to remove the pollutants from wastewater. Due to its natural processes, there is no need to add any input such as chemicals, mechanical pump or external energy. This reduces both the maintenance and energy cost. To accomplish this, the root zone wastewater treatment undertakes the following steps. So, pre-treatment done in settler, a device that separates the liquid from the solid. First treatment takes place in an anaerobic baffled reactor, a device with several identical chambers through which the effluent moves from top to bottom. Second treatment happens in an anaerobic filter, a device filled with filter media through which the effluent moves from top to bottom. And in third stage, the treatment takes place in a planted gravel filter, a structure filled with gravels material and planted with water resistant reeds plant which provide oxygen to the passing effluent. So as you can see in this diagram, the 4 steps are as follows. First is sedimentation, second is anaerobic baffled reactor, third is anaerobic filter and fourth one is planted gravel filter. So in settler, the sewage is passed and the settleable particles or particles which has the specific gravity greater than water, those particles are settled down in this tank. So then the effluent from settler is go to the anaerobic baffled reactor. So as you can see in this figure, there are number of baffles which are provided parallelly in this tank. So the depth of tank is more than 3 meter. Because of that, the anaerobic conditions happen in this. So velocity reduced. Because of reduced velocity, the sedimentation happens and clearer water we can collect it from this outlet pipe. Then this effluent which then go for anaerobic filter. So in anaerobic filter, the different filter media which are placed into this filter tank. So the filtration takes place. So the sewage can pass in vertical movement and filtration can take place. And again the clean water from these tanks is go to the planter gravel filter. So in planted gravel filter, the roots of these plants are working to remove the physical and chemical parameters from the sewage, and then the finally cleaner water should be collected from this chamber. So this technology is used as a decentralized wastewater treatment for small capacity of flow or for small household, and the wetland is used for the larger areas. So wetland requires a large area and this root zone technology requires a smaller area. So advantages of root zone technologies are: by its treatment and construction features, decentralized wastewater treatment is designed to limit operation and maintenance requirement and in the same to ensure high treatment standards even for shock loads. Minimum need for external energy. Using gravity instead of pumps, avoiding valves. Zero maintenance and low operating cost. Thank you.